Hi, 6th graders. We're starting chapter 4, so we're on lesson 4.1. So make sure you have a fresh spot in your notebook, a blank page. You can write down the learning target, which is expressing a whole number as a product of prime factors, which is what prime factorization is. So you want to write down that vocabulary term, and you can circle it and kind of write an arrow up to the learning target so you know that that's the definition. So prime factorization is writing a whole number as a product of prime factors. So just to review, a prime number is a number that has two factors, itself and 1. So 2, we know, can only be divided by 2 and itself to get a whole number. 5, 7, 13, 29, they're all examples of prime numbers. So 13 can only be divided by 13 or 1 to get a whole number. We know that all these numbers can be divided by other numbers, but we would end up with a decimal or a fraction. Composite numbers have more than two factors. So if you look at 100, we know that it can be divided by 2 and 5 and 10 and 25 and 50 and I forgot 4. So lots of different numbers that it can be divided by to get whole numbers. 4 can be divided by 1 and 2 and 4. So if we list out the factors of 12, I know that 12 can be divided by 1, so we're going to always start with 1, and I also know that it can be divided by itself. So every number, when you list out the factors, we start with 1 and then we end with itself. So then we can kind of go in order and we can fill in between. So I know that 12 can be divided by 2, and 2 times 6 is 12. So we're going to add 6 into our factors. I know that 12 can be divided by 3, and I know that 3 times 4 is 12, and that has filled it in. So once we come to where there's no gap between our numbers, kind of on both sides of the two numbers that can be multiplied by, then we know that we're done. So 1, 2, 3, 4, 6, and 12 are all factors of 12, or they're numbers that 12 can be divided by to get a whole number. So if we did 30, we know we start with 1, we end with 30. We know that it can be divided by 2, and 2 times 15 is 30. We know that it can be divided by 3, and 3 times 10 is 30. We know it can't be divided by 4, but we know that it can be divided by 5, and 5 times 6 is 30, and then we're done. So 1, 2, 3, 5, 6, 10, 15, and 30 are all factors of 30. So when we talk about the prime factorization of a number, we are talking about factoring it out so that we get to the lowest terms of all prime numbers. So there's two different methods that we're going to talk about of how to prime factorization a number. So our first method is factor trees, which you for sure want to write down. You may have wanted to write down this information if it was not very familiar to you anymore, just for a good reminder. If you knew it and you are good to go, then you may not need to write it down. So if we take 12, and our method is factor trees, so we are going to start factoring out 12. So I'm going to think of two numbers that can be multiplied together to get 12, and I know that 2 and 6 multiplied together equals 12. So then I ask myself if any of these numbers are prime numbers. And 2 is a prime number, so I'm going to circle it because we are done. 2 can't be factored out anymore. 6 is not a prime number, so it can be factored out a little bit more. So we have 2 and 3 multiplied together equals 6. So 2 is a prime number and 3 is a prime number. So I'm always going to circle it once I come to a prime number. Now I'm going to write out, because I have all of my lowest numbers are circled, so I have no other numbers that I can factor out. So now I'm going to multiply it out from least to greatest. So we have 2 times 2 times 3. And then the way that we write it, I know that 2 times 2 is the same as 2 squared, because we have 2 2's. And then I just have 1 3. So we have 2 squared times 3. Or we would say 2 squared, and then we're going to put our little multiplication sign in there. And it's nice to keep using our dot instead of x, because we'll eventually have variables in here. So our prime factorization is 2 squared times 3, and we can check it because 2 times 2 is 4 times 3, which equals 12. So there's a different, so using the factor tree, and using different factors, we can get a different factor tree, but with the same answer. So I also know that 3 times 4 equals 12. And 3 is a prime number, so I'm going to circle that. So right away when I come to a prime number, it's important to circle it so that it's not left hanging, and then later on when you're trying to collect all your prime numbers on the bottom, it's easier to see it if it's circled or squared or something like that. So 4 is not prime, so we're going to continue to factor that out. So I know that 2 and 2 equals 4. And 2 and 2 are both prime numbers. So then we're going to write it out from least to greatest. 2 times 2 times 3, which we can check. 2 times 2 is 4, times 3 equals 12. So then we rewrite it again as 2 squared times 3. Okay, let's do 30. So if we have 30, one way that we can factor out 30 is we could start with 3 and 10. I know that 3 is prime, so I'm going to circle it, and then I'm done with 3, because 3 cannot be factored out anymore. 10 can be factored out some more, so I know that 2 times 5 equals 10. 2 and 5 are both prime numbers. So now I'm going to rewrite it with my lowest number first. 2 times 3 times 5, and we double check. 2 times 3 is 6, times 5 equals 30, but we have no duplicates of numbers, so then our prime factorization is just 2 times 3 times 5. We could also do, 5 and 6 to get 30. 5 is a prime number, so I'm going to circle it and then be done. And 6, we know that 2 and 3 multiplied together equals 6. So I'm going to circle my 2 and circle my 3 because 2 and 3 are both prime numbers. And then rewrite it 2 times 3 times 5. Okay, so we're always looking for two numbers multiplied together to get the number right above it. Okay, and then we're looking to see if any of the numbers are prime numbers, and that's when we stop. Otherwise, we keep going and going and going until we have all prime numbers on the bottom. Pause me and factor out 200. So you may have done it differently than me, but I know that 25 times 8 equals 200. Both of these numbers are not prime numbers, so I'm going to keep going because I know that 5 times 5 equals 25. 5 is prime. And 5 is prime, so notice how I circle it right away before I go on to my other number. 8 is not prime, so I'm going to keep going. 4 and and 2 multiplied together equals 8. I know that 2 is prime, but 4 is not, so I'm going to continue on. And then 2 and 2 multiplied together equals 4. So then I'm going to circle both of my 2's. So now I can see that all of my bottom numbers are circled. So now I can figure out what my prime factorization is going to be. So I'm going to rewrite all of my numbers. I have 3 2's. And sometimes you'll have quite a few numbers. So if you want to do like a little dot to make sure that you get all the numbers or cross them out or whatever you want to do. So 2 times 2 times 2, and then we have 2 5's. And we're going to double check to make sure. So 2 times 2 is 4, times 2 is 8, times 2 is 40, and then 40 times 5 equals 200. So we know that it works. So now I'm going to rewrite this as 2 cubed, because we have 2 times 2 times 2, we have 3 2's, and then 2 5's. So 2 cubed times 5 squared. And then that is how we would write our prime factorization. Okay, so our second method of prime factorization is called division of primes. And it's very similar to what we would do for the factor trees, except we write it out just a little bit differently. So if I look at 50, I know that 50 can be divided by 2, and I get 25. So we write it just a little bit differently. Okay? Well, 25 is not done being factored, so or 25 is not a prime number, so we can keep going. So I know that 25 can be divided by 5, and then we have 5 on the bottom. 5 is done being factored. 5 is a prime number. So now I look at my numbers on the outside of my boxes, and I have a 2 and a 5 and a 5. And if we multiply those together, 2 times 5 is 10, times 5 is 50. So then we would write it as 2 times 5 times 5. And then our prime factorization would be 2 times 5 squared. Notice how I have my lower number first, so 2 is less than 5, and then I made 5 an exponent to the 5 squared because I have 2 5's. Okay, so if I have 36, and now so the way that we divide these is we think of prime numbers that it can be divided by, so it's a little bit more thinking. Instead of just picking 2 random factors, we're thinking of, well, what's a prime number that 36 can be divided by? And I know that 36 can be divided by 2. So 36 divided by 2 would be 18. I know that 18 can be divided by 2, which is a prime number. So then we have 9. And then I know that 9 can be divided by 3, which is a prime number. And then we end up with 3. Okay, so as you can see, we're putting only prime numbers on the outside here. So 2 times 2 is 4, times 3 is 12, times 3 is 36. So we're just thinking of numbers or prime numbers that each number is divided by. So then I would rewrite it as, 2 squared times 3 squared. Okay? We'll do one more. So 110 we know can be divided by 2. So 2 is kind of an easy one. If we know that it can be divided by 2, 2 is an easy one to start with because we know it's prime. So 110 divided by 2 would be 55. 55 cannot be divided by 2, but I know that it can be divided by 5, which is a prime number. 55 divided by 5 is 11. So then we have 2 times 5, which is 10, times 11 is 110. So that's our prime factorization. And then the last thing that we're going to talk about is if we have a number with a variable, which we can remember is an algebraic expression. So we can also prime factorize these types of expressions. So I'm going to rewrite this as 24 times x times y. We don't know what x and y are, so we're just going to leave x and y alone right now. And I wrote it out as 24 times x times y because a number with a variable means multiplication. So then we factorize out 24, so we have 4 and 6, and I'm going to do this really fast. And then I know that 4 can be factored out to 2 and 2, and 6 can be factored out to 2 and 3. And then if I rewrite it, I have 2 cubed because I have 3 2's, 1 3, 1 x, we can't forget our x, and we can't forget our y. So I should have gone in and circled my 2 and my other 2 and my 3 and my x and my y. So 24xy would be prime factorized out into 2 cubed times 3 times x times y. Okay, we're going to do one more. 36g squared times h squared. So we have 36 times g squared times h squared. So 36 can be factored out to 6 and 6, and then we know we have 2 and 3 and 2 and 3. G squared is actually the same as g and g, and h squared is the same as h and h. So then we know we have 2 2's, so then we would have 2 squared times 3 squared, because again, I know that these are all my prime numbers. And then we have, even though we don't know for sure, but we know that we factored it out as much as it could, but then we're going to change it back to g squared and h squared. So when you write out factors like this, you write the numbers from least to greatest, and then you write the letters in order of the alphabet. So 2 squared times 3 squared times g squared times h squared is how 36g squared h squared would be factored out. All right, so if you need to go back and rewatch this video because you are confused, make sure you do so. Make sure you write down any questions in your notebook that you have to bring to class tomorrow, and make sure you log into NICU and take the 4-1 quiz. Have a super evening.